Hello everyone, today we will discuss advance in the application of ultrasound in non-destructive testing, commonly known as NDT. Ultrasound refers to sound waves with frequency higher than 20 kHz, which are beyond human hearing. In industrial application, much higher frequency are used to inspect material and structure. NDT testing is a testing method used to evaluate material without causing damage. This is important because industry need to ensure safety and quality without destroying expensive equipment or products. Ultrasound testing works based on wave particles. Sound waves travel through material and reflect when they encounter defects such as crack or voids. This process involves concepts such as wave propagation, reflection, frequency, wavelength, and attenuation.
It is possible to investigate whether there are discontinuities under the surface using ultrasonic sound waves. Ultrasound has such a high frequency, people cannot hear it. The vibrations can, however, be measured with sensitive measuring equipment. Using this storage vessel, a weld is checked for internal discontinuities. First, the object being examined must be cleaned and free of any material that may interfere with the exam. Simply said, it works as follows. Sound waves are transmitted into the material with a transducer, and an echo is sent back from the rear wall or discontinuity. By registering this echo, we can deduct the thickness of the material, or if a discontinuity is present. In case of a discontinuity, sound is echoed back faster. Thus, we can see if the material wall is thinning, for instance by corrosion. The examiner first applies a contact fluid to enable the ultrasonic feeler to make proper contact with the material. This bonding layer serves to conduct the sound waves into the material. Without the contact fluid, they would immediately bounce back from the surface. A transducer converts an electronic signal into ultrasonic sound waves. It can both send and receive. The ultrasound equipment captures the reflected waves and converts this into a visual signal. This enables the examiner to see whether there are any discontinuities. If there is an indication, the exact location can be determined using calculations.
In scientific instrumentation, an ultrasonic transducer plays an important role. It converts electrical energy into ultrasonic waves and receives reflected signal to detect internal flaws.
Now, I will explain how ultrasound is used in non-destructive testing or NDT. Ultrasound NDT use high-frequency sound wave to check the condition of material without damaging it. One common method is plus echo method. Sound waves are sent into the material and the wave that bounce back are analyzed. If there are any crack or defect inside, the reflected signal will be different. This helps inspector find the location of the defect. Another method is through transmission method. In this method, one probe sends sound wave while the another probe receives them on the opposite side. If a defect block wave, the received signal will become weaker, indicating the possible defect. The main equipment includes an ultrasonic transponder which send and receive the sound wave, a signal processor that analyzes the signal, and the digital display system that show the result. Ultrasonic testing have improved greatly with new technology. One important advancement is fast array ultrasonic testing or PHY. It uses multiple sound wave sources to create clearer and more detailed image, making defect easy to detect. Another advancement is use of robotic inspection system which can perform inspection more efficiently and reduce human error. Today, AI technology can also help analyze inspection data faster and improve reliability. This advancement make ultrasonic testing more accurate, efficient, and reliable. Most importantly, it is non-destructive, meaning the material can be inspected without being damaged. Because of these advantages, ultrasound NDT is widely used in industry such as aerospace, construction, and manufacturing.
Ultrasound non-destructive testing is widely used in many industries because it helps identify hidden defects without damaging materials. In the aerospace industry, ultrasonic testing is used to inspect aircraft structures, landing gear, and engine components to detect internal cracks and ensure passenger safety. In the oil and gas industry, ultrasonic testing is commonly used to inspect pipelines, pressure vessels, and storage tanks for corrosion, wall thinning, or internal damage that may cause leaks or accidents. In manufacturing, ultrasonic testing helps inspect metals, pipes, and industrial components during production to ensure product quality and structural reliability. In the construction and infrastructure sector, ultrasonic methods are used to inspect bridge, steel structures, and concrete systems to identify hidden structural weakness before major failures occur. The use of ultrasound in non-destructive testing provides several important benefits. Firstly, it offers high accuracy and sensitivity, allowing even very small defects to be detected before they become dangerous. Secondly, ultrasound testing is considered safe because it does not involve harmful radiation unlike X-ray testing methods. Thirdly, it provides cost efficiency since industries can inspect equipment without destroying expensive materials or interrupting operations. In addition, ultrasonic testing is highly versatile because it can inspect internal structures that are not visible externally and can be applied to many different materials and industries. Therefore, ultrasound non-destructive testing plays a critical role in ensuring safety, quality, and reliability across multiple industrial sectors.
Despite its many advantages, ultrasound non-destructive testing still faces several challenges. Firstly, the technique requires trained and experienced operators because interpreting ultrasonic signals can be complex. For example, incorrect interpretation may lead to inaccurate results. Secondly, the equipment used for ultrasonic testing can be expensive, especially advanced systems such as phased array ultrasonic testing. Another challenge is the inspection of components with complex shapes. For instance, curved or irregular surfaces may affect the transmission and reflection of ultrasonic wave, making defect detection more difficult. In addition, proper surface preparation is often necessary to ensure good contact between the probe and the test material. Material characteristics such as grain structure and thickness may also influence the accuracy of measurements. The future of ultrasonic NDT is driven by rapid technological advancements. One important development is the integration of artificial intelligence. AI systems can automatically analyze ultrasonic data, identify defects, and reduce human error. Robotic inspection systems are also becoming increasingly popular. These robots can perform inspection in dangerous or hard-to-reach environments, improving both safety and efficiency. Furthermore,
Advances in imaging technology provide clearer and more detailed visualizations of internal structures. This helps inspectors make more accurate decisions. Portable and wireless ultrasonic devices are also being developed, allowing inspections to be performed more conveniently in the field. In addition, the ultrasound entity is increasingly integrated with Industry 4.0 technologies, enabling real-time monitoring and predictive maintenance in smart manufacturing environment. In conclusion, ultrasound plays a vital role in non-destructive testing by enabling safe, efficient, and accurate inspection of materials and structures. Its ability to detect internal defects without causing damage makes it one of the most valuable tools in modern industry. With ongoing developments in artificial intelligence, robotics, and advanced imaging systems, ultrasound entity is expected to become even more accurate, efficient, and widely adopted in the future.